Computing is advancing at incredible speeds. The engine propelling this rocket is accelerated computing, and its fuel is AI. Today, we will show you new advances in Nvidia RTX, Nvidia AI, and Nvidia Omniverse. How these platforms propel new breakthroughs in AI, new applications of AI, and the next wave of AI for science and industry. We will announce new chips that power these new applications, and for the first time, cloud services to extend the reach of Nvidia platforms. I want to thank all the sponsors, partners, researchers, developers, and customers who join us to make this event amazing. Welcome to GTC. I want to show you something amazing. Racer X is a fully interactive simulation built with Nvidia Omniverse. Racer X is physically simulated. The lighting, reflections, and refractions are ray traced. Nothing is pre-rendered and baked in. The parts and joints of the cars are individually modeled. Their physical properties affect driving dynamics. Things in the environment are not static props, but rigid body, cloth, and fluid simulations. Smoke, fire, and dust are volumetric simulations. Racer X is a simulation. Future games will not have pre-baked worlds. Future games will be simulations. Racer X is running on one single GPU. We did it. We introduced the programmable shading GPU nearly a quarter of a century ago. GPUs revolutionized 3D graphics and created a medium with an infinite palette for artists. At SIGGRAPH 2018, we launched Nvidia Rtx, a new GPU architecture that extended programmable shaders with 2 new processors. RT cores accelerate real-time ray tracing. Tensor cores process matrix operations central to deep learning. RTX opened a new frontier for computer scientists, and a flood of new algorithms have appeared. a new era of RTX neural rendering has started. Today, we're announcing Ada Lovelace, our third generation RTX. One Ada GPU powers Racer X. This generation is named after mathematician Ada Lovelace, who is often regarded as the world's first computer programmer. NVIDIA engineers worked closely with TSMC to create the 4N process, optimized for GPUs. This process lets us integrate 76 billion transistors and over 18,000 CUDA cores, 70% more than the Ampere generation. Ada evolves all three RTX processors. First, a new streaming multiprocessor with 90 teraflops, over 2 times the previous generation. Ada's SM includes a major new technology called shader execution reordering, which reschedules work on the fly, giving a 2 to 3 times speed up for ray tracing. SCR is as big an innovation as out-of-order execution was for CPUs. Second, a new RT core with twice the ray triangle intersection throughput and 2 important new hardware units. A new opacity micromap engine speeds up ray tracing of alpha test geometry by a factor of 2 times. And a new micromesh engine which increases geometric richness without the BVH build and storage cost. And third, a new Tensor Core with the Hopper FP8 transformer engine and 1.4 petaflops of tensor processing. Raw ray tracing horsepower is not enough to ensure high frame rates. Ray tracing is notoriously hard to parallelize because rays bounce in every direction and intersect surfaces of various types. GPUs are highly parallel and most efficient when processing similar work at the same time. Ray tracing workloads lead to different threads processing different shaders or accessing memory that is hard to coalesce or cache. Shader execution reordering, SER, improves execution efficiency by rescheduling shading workloads on the fly to better utilize the GPU resources. We're seeing up to 2 to 3 times increase in ray tracing and 25% in overall game performance. Like accelerated computing, computer graphics is a full stack challenge. Breakthroughs require innovation in architecture and design, as well as algorithms. For example, NVIDIA's RTX GI uses ray tracing to do real-time multi-bounce indirect lighting. RTX DI uses ray tracing to do direct illumination from millions of lights, casting shadows from all lights. RTX DI is used for emissive surfaces, such as billboards, TV screens, neon tubes. NVIDIA real-time denoisers is a spatial temporal denoising technique that takes an incomplete ray-traced image and infers the ground truth, reducing the number of rays needed. And DLSS, Deep Learning Super Resolution, is one of our greatest achievements. Ray tracing requires insane amounts of computation. Each frame of a CGI movie takes hours to render. We want to do this in real time. NVIDIA RTX opened the world to real-time ray tracing. RT cores do BVH traversal and ray triangle intersection testing, which saves the SMs from spending thousands of instructions on each ray. But even with RT cores, frame rates were too low for games. We needed another breakthrough. Enter deep learning. DLSS uses a convolutional autoencoder AI model and takes the low-resolution current frame and the high-resolution previous frame to predict on a pixel-by-pixel basis a high-resolution current frame. The AI model is trained to predict an ultra-high-resolution 16K reference image. The difference between the predicted and reference image is used to train the neural network. The process is repeated tens of thousands of times until the network can predict a high-quality image. Ada introduces DLSS 3, a new AI that generates entirely new frames rather than just pixels. DLSS 3 has 4 components: a new optical flow accelerator, game engine motion vectors, a convolutional autoencoder AI frame generator, and our reflex super low latency pipeline. DLSS 3 processes the new frame and the prior frame to discover how the scene is changing. The optical flow accelerator provides the neural network with the direction and velocity of pixels from frame to frame. Pairs of frames from the game, along with the geometry and pixel motion vectors, are then fed into a neural network that generates the intermediate frames. DLSS 3 generates entirely new frames without processing the graphics pipeline, boosting game performance by up to 4 times over brute force rendering. Because DLSS 3 generates a new frame without involving the game, it benefits both GPU and CPU limited games. For CPU limited games, like physics heavy or large world games, DLSS 3 allows the Ada GPU to render the game at a much higher frame rate than the CPU is able to compute the game. DLSS 3 is one of our greatest neural rendering inventions. Here is Cyberpunk 2077, shown in all new max ray tracing mode with SCR and DLSS 3. Pushing the state-of-the-art graphics into the future takes an incredible amount of computational horsepower. In a modern game like Cyberpunk, we run over 600 ray tracing calculations for every pixel just to determine the lighting. That's a 16 times increase from the time we first introduced real-time ray tracing 4 years ago. Yet the number of transistors we have available in a GPU to do these calculations have not increased at that rate. That's the power of RTX. We can deliver a 16 times increase in 4 years with artificial intelligence. Some pixels are calculated, most are predicted. Let's enjoy Microsoft Flight Simulator, a game that is CPU limited because of the realistic physics and the giant worlds. It is one of the longest running franchises. This is Flight Sim's 40th anniversary. With Ada and DLSS 3, Flight Simulator is silky smooth. I am thrilled to announce Portal RTX. Nvidia Lightspeed Studios used Omniverse to remaster one of the most celebrated games in history. Portal was developed by Valve and released in 2007. It was GTC'de Game of the Year and exhibited at the Smithsonian. Portal RTX is both nostalgic and futuristic at the same time. Let's take a look.
This was a triumph. I'm making a note here, huge success. We do what we must because we can. For the good of all of us, except the ones who are dead. Welcome to the Aperture Science Computer Aided Enrichment Center. Cake and grief counseling will be available at the conclusion of the test. The Enrichment Center regrets to inform you that this next test is impossible. What are you doing? Stop it.
Portal with RTX is a mod. We did it with Omniverse. Modding is a massive culture. Everyone is a creator. There are millions of modders, and billions of mods are downloaded each year. In fact, 9 of the 10 most popular competitive games owe their existence to mods. We created an Omniverse application called RTX Remix for game modding. Start the game and capture the game into USD, which is loaded into Omniverse. Here, we're using Elder Scrolls Morrowind from Bethesda, one of the top modded games of all time. Once in RTX Remix, the AI-assisted toolset has deep learning models to up-res textures and assets, and an AI model to convert materials to have physically accurate properties. The rich Omniverse ecosystem of creative tools can then be used to enhance the game assets. When done, export the RTX mod pack and play the game with the RTX renderer. RTX Remix is incredible tech and the most advanced game modding tool ever created. Portal RTX and RTX Remix will be available shortly after Ada launch. RTX neural rendering algorithms run on programmable shaders, RT cores, and tensor cores to create amazing images. The total processing throughput of Ada is a massive leap over the Ampere generation, and the performance shows. For rasterized games, Ada is up to 2 times faster, and it's 4 times faster for ray-traced games. Ada is incredibly energy efficient, over twice the performance at the same power compared to Ampere, and you can really push Ada. We've overclocked Ada past 3 gigahertz in our labs. RTX reinvented graphics. Now Ada is paving the way for future games to be fully simulated worlds like Racer X. Today we're announcing our highly anticipated Nvidia Ada Lovelace GPU, the GeForce RTX 4090. Nvidia engineers push technologies on every front. New SM with shader execution reordering. New RT core with opacity micromap and micro mesh engines. New tensor core with FP8 transformer engine. And a pixel processing 300 TOPS optical flow accelerator for DLSS 3. Overall, 4 times more processing throughput. Compared to the world's reigning GPU champion, the 3090 Ti, 4090 is 2 times faster on Microsoft Flight Simulator, 3 times faster on Portal RTX, and 4 times faster on Racer X. The GeForce RTX 4090, the new heavyweight champ, is $1599. Available October 12th. The GeForce RTX 4080 comes in 16GB and 12GB versions. 4080 is 3 times the performance of 3080 Ti on Racer X. 4080 starts at $899. The best gaming platform in the world just got better. Our 30 series, starting at $329, are the best GPUs in the world serving mainstream gamers. RTX 4090 and RTX 4080 GPUs, starting at $899, deliver the ultimate performance to enthusiasts. The Ada Lovelace generation advances all 3 RTX processors, the engines of neural rendering. Ada is a quantum leap for gamers and paves the way for creators of fully simulated worlds like Omniverse. Welcome to the Omniverse. The next evolution of the internet, called the metaverse, will be extended with 3D. Today's internet connects websites described in HTML and viewed through a browser. The metaverse, the 3D internet, connects virtual 3D worlds described in USD and viewed through a simulation engine. Omniverse is a platform for building and operating metaverse applications. Omniverse is useful wherever digital and physical worlds meet. One of the most essential uses of Omniverse is robotics, the next wave of AI, where AI interacts with the physical world. Omniverse is like nothing ever built. Omniverse is a real-time, large-scale 3D database. It is a shared 3D world. Omniverse is a network built on USD. It connects 3D worlds. Omniverse is a computing platform. You can write applications that run on Omniverse. These applications are like portals into the Omniverse virtual world. We've written some Omniverse applications like Create and View for collaboration, Replicator for synthetic data generation, and IsaacSim and DriveSim for digital twin simulations. We are releasing a major update to Omniverse. Support for Ada Lovelace GPUs with a giant leap in ray tracing and large scene performance. New GAN-based and diffusion model-based neural rendering tools. Omnigraph is a graph execution engine to procedurally control behavior, motion, and action. A major update of Omniverse physics to process kinematics of complex multi-part objects. New Cloud XR for Ada's amazing ray tracing in VR. The world's first SIM-ready asset library for synthetic data generation and digital twin simulations. One of the most popular applications of Omniverse is Replicator, which is used to generate synthetic data to train self-driving cars, robots, and all kinds of computer vision models. New Omniverse JT connector. This is big. Siemens invented JT, the industry standard language of product lifecycle management and the interoperability format of CAD systems like NX, Creo, CATIA, and Inventor. The JT connector opens the industrial and manufacturing worlds to Omniverse. Omniverse is an enterprise platform that is useful from the beginning of design and styling, through engineering and manufacturing, marketing to operations, the entire product lifecycle. At the core of making movies or games, building cars or any consumer product, or building and operating factories and warehouses is a super complex 3D pipeline. Let's take a look at the creative and design process. Many specialized tools are used by expert designers, artists, and engineers, working in different teams, organizations, or geographies, passing work around. Different data formats are stored all over the company. A visual effects pipeline can use 5 to 7 tools. Each specializes in a certain aspect of the workflow, such as modeling, rigging, animation, or simulations. DNEG, an award-winning visual effects and animation studio, uses Autodesk Maya, SideFX Houdini, Adobe Substance 3D, and Foundry Nuke in their workflow. Just as the internet connects websites, Omniverse connects 3D worlds. Omniverse lets DNEG's creators bring in data from different tools in their full fidelity and collaborate interactively in a shared Omniverse world. Teams can create a custom 3D pipeline to orchestrate and manage the complex workflow using simple out-of-the-box Omniverse tools. These Omniverse capabilities are valuable to nearly every industry. Nvidia Racer X was created by 30 artists using 11 tools, collaborating across 12 time zones, and done in only 3 months. The team used Omniverse to connect and collaborate and create a custom 3D pipeline to orchestrate and manage their work. The architectural design process commonly uses apps like Revit, Rhino, SketchUp, ArchiCAD, and 3ds Max. KPF, an award-winning architectural design firm, connects architects, designers, and clients in Omniverse. Clients can review progress by interacting with a full fidelity and photorealistically rendered model. Auto and other physical product makers commonly use Siemens, Autodesk, Ansys, and PTC tools. GM is creating a digital twin of their Michigan design studio in Omniverse, where designers, engineers, and marketers can collaborate. Omniverse gives them a single source of truth that is physically simulated and faithfully rendered. Omniverse is a virtual world used to design, build, and operate things in the physical world. In the future, everything made will have a digital twin used by the makers to emulate the behavior and performance of a product in the physical world. No physical product operated by software can be deployed in large numbers without testing the software on its digital twin. Let me give you some examples. Telcos will deploy millions of 5G microcells and towers over the next 5 years. Optimizing the placement and operations of new and existing cells and towers can save billions for the $2 trillion telecom industry. Charter, a $50 billion telecommunications provider, and Heavy AI, a super cool interactive data analytics platform company, are using Omniverse to create digital twins of their 4 and 5G networks at metro and nationwide scales. Heavy AI uses Omniverse to combine multi-billion point LiDAR scans, satellite imagery, buildings, trees, and surroundings, and their RF propagation model to simulate the performance of Charter's radio network in real time. Lowe's is one of the world's largest home improvement retailers, with over 2,000 stores and 300,000 retail associates. Lowe's is using Omniverse to design, build, and operate digital twins of their stores to optimize operations and enhance the shopping experience. And with the amazing Magic Leap 2 headset connected to Omniverse, associates can enter a mixed physical and Omniverse world to explore new store designs. The $300 billion global railroad market helps move the world, a critical part of the global supply chain. Deutsche Bahn, the national railway company of Germany, uses Omniverse to build and operate a digital twin of 5,700 stations and 33,000 kilometers of track. Omniverse is also used to train AI models that can continuously monitor the railways and trains and recognize hazards and situations that can affect network operations. Deutsche Bahn expects to increase capacity and efficiency of the railway and reduce its carbon footprint without building new tracks. Each of these stories are amazing. Be sure to check out their videos on the NVIDIA homepage. There are many great examples of how companies use Omniverse to create digital twins of factories, logistics warehouses, automated manufacturing lines, and industrial plants. Let's take a look. Connections to Omniverse are growing fast. There are already 150 connectors to Omniverse. These are the tools and platforms used by the world's $100 trillion industries. These connectors open Omniverse to companies that span the largest industries, from retail, transportation, telecommunications, manufacturing, media and entertainment, consumer and luxury goods, to supply chain and logistics. Here are some examples of companies who are using Omniverse to connect their teams, visualize their data in full fidelity, generate synthetic data to train AI models, and simulate digital twins. Omniverse is a new computing platform and requires a new computer system. There are three elements to the Omniverse computer: RTX computers for creators, designers, and engineers; OVX servers to host connections to the Nucleus database and run virtual world simulations; and third, the Nvidia GDN, portals into the Omniverse. Through GeForce Now, we've built a global GDN, a graphics delivery network that reaches 100 regions with super fast and responsive RTX graphics. Whereas a content delivery network, or CDN, allows internet video to be streamed efficiently, Nvidia GDN can stream interactive graphics efficiently. Between Nvidia RTX PCs, Nvidia GPUs in the cloud, and Nvidia GDN, we can build an Omniverse computer that covers the planet. Let me show you how Rimac, a hypercar and advanced EV platform company, uses Omniverse to connect their design, engineering, and marketing pipelines to create the amazing Navara. Rimac designs on RTX workstations and publishes the Omniverse-based car configurator application to run on Nvidia GDN, which is then streamed to be enjoyed on any device.
NVIDIA Omniverse Cloud is a suite of software and infrastructure as a service for designing, publishing, and experiencing metaverse applications from anywhere on any device. Let's see how Rimac, technology pioneer of AI-enabled hypercars and advanced electric solutions, can enable collaborative workflows for their 3D teams and deliver advanced 3D experiences to their audiences with Omniverse Cloud. The 3D models of cars such as Rimac's are designed by large teams of uniquely skilled individuals, each using their own specialized tools. Here, designers connect to Omniverse Nucleus Cloud, their shared database engine. With USD workflows, they can aggregate full CAD fidelity datasets from their favorite tools, including Autodesk Alias, Houdini, Adobe Substance 3D Painter, and Omniverse Create. Each designer either works on their individual RTX computers or streams Omniverse apps from OVX servers in the cloud. Once complete, Rimac integrates the ground truth USD model into an advanced real-time 3D configurator and publishes it to the NVIDIA Graphics Delivery Network, a planetary scale network of distributed data centers that stream high-performance, low-latency 3D experiences to edge devices. Today's configurators are limited by pre-rendered options that can only be shown in a single scene. With the end-to-end USD pipeline, Rimac fans and consumers are configuring the actual engineering dataset, not a simplified model, in full fidelity with physically accurate materials and real-time RTX ray tracing. This unlocks all possible design permutations without Rimac having to manually render every option as a layer. Omniverse Cloud connects 3D artists, designers, and metaverse viewers at every edge of the planet and delivers the possibility to build and operate advanced 3D internet applications on any device.
Today, we're announcing NVIDIA Omniverse Cloud, an infrastructure as a service that connects Omniverse applications running in the cloud, on-prem, or on a device. In addition, Replicator and Farm will also be available in the cloud. Farm is a scaling engine for a render farm. Omniverse Cloud, Replicator, and Farm containers are available on AWS today. We're also offering them as managed services. Sign up today for early access. Robotics is the next wave of AI. Breakthroughs in deep learning has opened the door to creating systems that can perceive their surroundings, plan a sequence of actions, and perform useful tasks in real time, every time. Everything from the way software is developed to how it runs is completely different. A new type of processor had to be created. Nvidia's Xavier was the world's first robotics processor designed for deep learning. Since then, every 2 years, we've announced a giant leap in performance. The driving force of the increased performance is the simultaneous increase in number and resolution of sensors and more sophisticated AI models needed to expand driving domains and improve safety. Safety is the #1 priority in robotics, and it demands diversity and redundancy in sensors and algorithms. All of that demands more processing. Last year, we introduced Atlan, a 1,000 TOPS SoC. Today, we're announcing that Atlan is no more and will be replaced by Thor, twice the throughput of Atlan and more than twice the delivered performance. There are 3 big reasons we did that: Grace, Hopper, and Ada Lovelace. The incredible transformer engine of Hopper and the fast evolution of vision transformers is too important not to include in our next robotics processor. The invention of multi-instance GPU in Ada is a great opportunity to centralize the car computer, reducing hundreds of dollars of cost. And the CPU of Grace is too amazing to pass up. As all parallel processing algorithms are offloaded and accelerated by our GPU, the remaining workload tends to be single-threaded limited. Grace has excellent single-threaded performance. So engineers at NVIDIA scrambled to create Thor. The amount of new technology in Thor is insane. Thor can be configured in multiple ways, can dedicate all of its 2,000 TOPS and 2,000 teraflops to an autonomous driving pipeline. Or it can be configured to use a portion for cabin AI and infotainment and a portion for driver assistance. Thor's multi-compute domain isolation lets concurrent time-critical processes run without interruption. On one computer, you can simultaneously run Linux, QNX, and Android. Thor centralizes numerous computers and simultaneously offers a leap in capability while reducing cost and power. Today, parking, active safety, driver monitoring, camera mirrors, cluster, and infotainment are different computers. In the future, these functions will no longer be separate computers, but will be delivered by software that runs on Thor and improves over time. Building robotic computers requires 2 computers: an AI factory in the data center that processes data, trains the AI, simulates the digital twin, and maps the world, and an AI computer in the car that processes the sensors to perceive the environment, stay clear of obstacles, and drive the car to its destination. NVIDIA Drive is an end-to-end platform for autonomous vehicle development and deployment. For development, Drive includes Replicator synthetic data generation, NVIDIA AI infrastructure, Drive Sim, and Drive Map. For deployment, Drive includes the full-stack driving and in-cabin AI applications, the AI computer, and the Hyperion